Assalamu alaikum and greetings everyone. This is Salam Geographia and I'm going to be teaching some lessons on here and I'll be posting some videos. A couple of students have asked me to explain the atmospheric circulation model, so I thought it might be useful for me to make this video for students and maybe teachers as well. In this particular video, I'm going to go through the atmospheric circulation model in more detail and just kind of give you a little background as to what it actually is and to get your head around, because I know it can be quite a confusing model, but it doesn't have to be. So I'm going to run through the objectives for today, and also I'm going to ask you to maybe pause the video at certain points where you can just reflect on the questions I put on there. That's just for you to help you revise, or just to help you get to grips with what you're seeing in front of you. So, make yourself a cup of coffee or, tea or whatever drink you want, and just try to just absorb this information and try to enjoy the learning as well. Okay, so what we're going to do is we're going to try to understand how the global circulation system works, and also all the components involved. And secondly, we're going to look at how to make connections with the major climate zones of the world. We're not going to go into too much detail. We will save that for another lesson, but we're just going to try to make sense of all these things. The first thing I want you to do is just have a look at this picture. Now, it's an interesting state of atmosphere that you can see here. I want you to write down some questions about the atmosphere just to get you thinking and prepared. What comes to your mind when you see this image? What can you see? What kind of questions would you have for your geography teacher or for yourself when you're actually diving into this particular subject? Now you can pause the video here and have a look at this picture in more detail and just think to yourself. Now, for some of my Muslim viewers, you know the state of this sky because it tends to be at that time when it's the very first prayer, like the Fajr prayer. So this is what the clouds in the air kind of look like. There's this kind of like beautiful reddish kind of color in the sky. And I tried to take an image of that particular moment. It's like that first morning sky that you see. But I still couldn't capture the beauty, but I tried. But yeah, so just think to yourself what kinds of questions you could ask about the atmosphere. Now, here are some questions that I came up with. So they're to do with your GCSE basically. So you need to think about, why do we need to understand the global circulation system? What is meant by high and low pressure? And why are there different climate zones? These might be some of the questions that you feel you've asked, or you might have asked some other questions like, why is the sky looking so red? Why are the clouds in different shapes? Is it raining? What's the condition of the atmosphere? So there's so many questions that you could actually ask at this point. It's such a vast topic, but this is just basically to just get you thinking about the atmosphere in more detail. Now, your very first task will be to draw a giant circle. So if you've got like a tablet or something, or if you've got a notebook or something like that and a pen, it's good to have those pens with those 4 colors. Remember, being geographers, it's always good to use a bit of color so that you can make your notes, not number 1, look really nice, and number 2, you feel like reading your notes when they look nice. So draw a giant circle, and from memory I want you to think to yourself, where is the equator? Think about the 2 tropics, Tropic of Cancer and Tropic of Capricorn. Where are they located? And think about the 2 poles. Okay, so think how you would add that to this giant circle. So ideally what I'm looking for is for you to have some sort of A3 paper. If you can't get A3 paper, just get 2 A4 pieces of paper, sellotape them along the back, and just have a nice big kind of like open page, like, you know, like how you have a double page spread, something like that. So if you could organize that for me. So in the center, so I'm saying about 1/3 in to the paper. So in the middle, have a nice big circle. Place these different lines onto your giant circle. So I'm going to give you a few minutes to do that, or better still, pause the video and have a go at doing this from memory. And the challenge here is to add what many geographers call the temperate low pressure belts. Do we know what they might be as well? Okay, so if you could just add that to your diagram. Okay, so here we've got the very first line. I asked you to draw an equator. So what I was looking for is for you to just split the Earth. Yeah, that's correct. This circle was representing the Earth. So you've split the Earth into two halves. So you've got the northern hemisphere at the top and then the southern hemisphere. And then the next thing I asked you to do was to put in the two tropics, the Tropic of Cancer and the Tropic of Capricorn. And we'll be labeling them in a minute, but this is the kind of pattern I wanted you to form from memory. And then of course the two poles, the pole areas. Okay, so these are actually called belts. Okay, so we kind of refer to them as atmospheric belts. So it's important that we know about these, because these are going to be very, very important in us understanding how the whole atmospheric circulation model actually works. So let's add some more detail to our lines of latitude. So we've got the equatorial low pressure belt. Remember I said these are belts. So you've got to imagine the world with a giant belt, the biggest belt being the equator, the equatorial low. Okay, so this is a low pressure area, and we'll be talking about why it's a low pressure area in a minute, but I want you to just have that in your head, that this is an equatorial low pressure belt. And then you've got the subtropical high pressure belt. Okay, so that goes up top here, north of the equatorial low. And I haven't labeled it, but it's actually the Tropic of Cancer. Okay, so if you could label it the Tropic of Cancer. And then we've got the another subtropical high, which is mirrored to the south. Okay, and this also is a high pressure belt. And this is, of course, your Tropic of Capricorn. So remember, the Tropic of Cancer is in the north, and then you have the Tropic of Capricorn towards the south. Now, the challenge was to add the temperate low pressure belt. So those are these. Okay, so we find them towards the north and the south pole. How did you do? Okay, now add those two lines of latitude that I've just mentioned, the Tropic of Cancer up in towards the north, and then the Tropic of Capricorn towards the south. And I want you to just think to yourself, okay, we had this globe. I don't want to overcomplicate the diagram by keeping the different labels on there, so I've taken them off. So hopefully you've recorded them. If you haven't, you could just rewind back and record them onto your diagram, because I want to keep it simple. So you've got these lines of latitude, and you need to know what these lines actually mean as well. But I want you to just think first about what's happening at the equatorial sort of region. Okay, so remember we mentioned that this is your equatorial low pressure belt. So what's essentially happening here is you've got a case of hot air rising at that particular point. So remember, warm air is lighter and it rises, and it either goes towards the South Pole or it goes towards the North Pole. So that's why you have this kind of circular motion going either way. And as the air goes into the as the hot air rises, of course, what happens to it? Do you remember our Year 7 lessons? It condenses. Good. Well done if you got that right. So it condenses and it forms these huge clouds. And some of the biggest clouds are actually formed in this area because air cools to the temperature of surrounding air, and it becomes very the instability sort of rises. So you have things like convectional rain, and of course you have the formulation of the cumulonimbus clouds, which are the largest clouds that you can get. So a lot is going on in this area. And there's another thing that we have as geographers, and another sort of point that we make here is it's the ITCZ zone, which means it's a if you can maybe record this. I haven't actually put it in my video, but maybe I should have. But the convergence at the trade of winds, where there's an uplift and there's a low pressure around this area, and it's really important that we understand that it's the intertropical convergence zone. Okay, so that's the point where we have a lot of condensation happening in the air because there's a lot of hot air rising, and of course it's going to form into these giant clouds. So some of the clouds are going to move towards the South Pole and some of the clouds are going to be moving to the North Pole, and you've got to imagine things are happening kind of like a circular motion. So as the clouds move towards the, let's just say, north, the air begins to cool, right? So what happens to the air when it cools? Can you think? If you guessed it right, well done. It kind of drops. Okay, so you get a point where cold air begins to sort of descend. So air is cool and dry and it's descending, and we tend to have like a mild kind of weather in this area. And I've put two sun like spots there for you to consider in this area, because remember what happens in the north is also mirrored in the South Pole as well. So I want you to just kind of visualize this, that these are imaginary circles that you need to, like, circulation. This is an imaginary circulation model that you need to imagine in your head. Okay, so remember, in the middle where the equatorial low is, you've got hot air rising, and then it's forming a cloud, and then it's going in different directions, and then it descends. Okay, and then it goes back up into the air, and this circular motion keeps on happening. And where the hot air is rising on one side, the same thing would be happening on the other side to that as well. Okay, so these cells are now in motion. So there's some points at which you have cool air descending, and some places where the hot air is rising. So where the cool air is descending, if we have a look where the sun is, that particular point is either the Tropic of Cancer or the Tropic of Capricorn. Okay, so those are the tropical regions. So we get a lot of sun there. So if you think about all of those tropical rainforests and places like that, you've got lots and lots of sun, and of course you have lots of rain as well. So they all have names as well. Okay, so these cells do have names. So the two cells that are mirrored side by side, so like a symmetrical pattern. So from the equatorial region in the middle, where the red line is, you can see that you've got the Hadley cell, okay, and then the Hadley cell to the south as well. So remember, we turned our Earth to the side, because it's a spherical kind of shape, so it's like a ball, so wherever you position the Earth, you can visualize where the equatorial line might be. So as you can see, we've got Hadley cell forming towards the North Pole, and we've got Hadley cell forming towards the South Pole. Now, where the air is actually descending, you can see that we have the Ferrel cell formulating as well, and the same thing mirrored towards the North Pole as well. So as the cool air descends, then what we are seeing is temperatures rise again, and then hot air rising again, and those clouds forming less sort of heavy than what we saw in the sort of equatorial low kind of regions. And this also is a low pressure belt here as well. So it like the equator. So we've got hot air like rising. So that's the general pattern. After that point, you will see another cell forming, which is the polar cell. So it's really, you only need to learn 3 names. So we've got the Hadley cell, the Ferrel cell, and the polar cell. And those are the 3 cells that you really need to learn. So whatever's happening in the north is mirrored to the south as well. Now, just to make you understand a little bit more about the lines of latitude and longitude, I've taken this from Encyclopedia Britannica just to show you, what we're talking about, because it can get quite complex. Remember, lines of latitude are in terms of the location, scale, and direction, and we need to know the degrees at which those lines of latitude or those parallels are sort of located. So we as geographers know that the equator is at 0 degrees. Okay, so it's neither north nor south. So anything above, any belt that's above the equator is going to be a certain number of degrees towards the north. Okay, if that makes sense. So then you write, so in this example, you can see the first belt here is 10 degrees north. Okay, and then likewise, we can see towards the south, you've got 10 degrees south. And you can make out Africa here, right? The continent of Africa can be made out here. And then, of course, you've got Europe. And if you can see, you've got UK. So if I was to ask you, so roughly whereabouts can you see the UK? Which line of latitude can you see the UK at? Then you can kind of quite easily with this diagram see that it's between 60 degrees north and 50 degrees north. Okay, in that sort of temperate zone where it's quite mild. Because if we look back at our diagram, we will see, if I can get back to our diagram, which I don't think I can. Just give me 1 minute. Okay, I wasn't able to go back. But anyway, if we just have a look at this area, you can see that it's like we saw the clouds in our diagram were a little bit smaller. So remember, we had those cumulonimbus clouds here forming, and here we had slightly smaller clouds. So that would explain that, because it's a kind of low pressure area. So yeah, when we look at the parallels of latitude, we look at the distance between the 2 sort of directions, between the north and the south, and we assume the equator is at 0 right in the middle. Okay, that's saying that the equator is in the middle. Because it's a spherical shape, we can see like a little curve here. And that's really important for us to understand, because when we have a normal map, it tends to be a projection, like a flat projection, and that distorts the true sort of scale of the different continents. So sometimes Africa is shown really, really small, and Europe is shown huge, and places like Russia look bigger than they actually are, and places like Greenland. Okay, so what do we mean by degrees? I mean, it's just simple maths, really. So what we're saying essentially is if we look at this point here in the equator, we're trying to say that if we had a protractor, we would know that this is 90 degrees from the equator, okay? And 10 degrees is like this, okay? Can you see? So if you had a protractor, you could see 10 degrees, 20 degrees, 30 degrees, sorry, and then 90 degrees, like a right angle here. And that's what we're kind of talking about. It's just simple maths, and you just need to know that it's the radius towards the north if we're going upwards. So yeah, and the same applies to the south as well. So 90 degrees south, or 10 degrees or 20 degrees from a particular point. Great stuff. Okay, so as we've mentioned, the Earth is divided into the northern hemisphere and the southern hemisphere. And you can have, there's some notes here that you can actually add to your map just so that you have some understanding of what we mean by lines of latitude. There's also lines of longitude as well, and they're known as meridians. And of course, we know that there's a prime meridian, okay, and the prime meridian is right here, and we're saying that's at 0 degrees, and anything towards the east, okay, we add degrees. Sorry, east is going the other way. So here are all the east longitude meridians, and then we have the ones going towards the west. Okay, so they also have measurements of distance from east to west, and these distances are actually measurements taken from this prime meridian, which, as you can see, runs right through Greenwich, and you can actually see the line as well in Greenwich, because remember, it runs through the UK because the explorers of the time used to navigate from Britain, and it's a very like Eurocentric kind of mathematical concept, you know, because a lot of the explorers of the time were British, who were taking knowledge from different countries but making it their own, and then they made their own kind of maps, but they've kind of universally been accepted, but other countries have their versions as well as what might be the center of the earth. But what they've done is essentially applied world knowledge to their own European knowledge. But that's another lesson. So the earth can be quite complex to understand. So once you've visualized those imaginary lines, hopefully we can explain the pattern of air circulation more easily as well, and you know where you're positioned in the world as well. Have a few minutes to reflect on this diagram. You can pause the video and think to yourself, do I know, number one, can I name that cell? Number two, can I name that latitude line? Okay, so test yourself now, get yourself a scrap piece of paper and see if you can, from the top of your head, work out the answers to some of these questions to your left. Or you can pause the video. And you can rewind the video and just see if you got the answers right. Okay, now, just to kind of show you what your notes could look like, today we went through quite a lot, and this is what I meant. This is what I get my students to do. I get them to make a big giant revision sheet for themselves about the atmospheric circulation system, and I get them to draw that massive circle in the middle, and then they put all the major elements of that diagram in their like on their sheet of paper, and make sure that you use color, because it just kind of makes you want to learn from the sheet. You could stick that up on your wall or something, just so that you can just remind yourself, especially diagrams like this. I wouldn't stick every single thing up on my bedroom wall, but this kind of poster is really nice to have up on your wall, because then when people come in, like your cousins or your mates, they might just say, oh, that's an interesting diagram, and then you can explain it to them. And you know, sometimes when you're revising, the best thing you can do is actually have something like this up on the wall and just explain it to someone.